Hey there everyone. Some videos I absolutely love because they are the core of engineering discussion. And I love these kinds of videos where I can just openly go ahead and talk about the engineering solutions, not just the code part of it. Of course, code is a part of it, but some discussions are just general. So in this video, we have the core engineering discussion. We're going to see that why latency is so much important and you should be so much focused on that. We have a case study as well of an Australian university. You will have some of the reading materials with that, and you will have actionable insights after this video to make sure that your website or whatever the product you are building is going through with all the hardships of the internet and still performs the best. So welcome on board. Hey there everyone, my name is Hitesh and I make a lot of videos on YouTube regarding coding as well as general tech discussion. So in case this sounds interesting to you, do hit that subscribe and do drop me a comment that do you really enjoy these kinds of videos? Let me know in the comment section. Let me take you up onto the screen, and first of all, I would love to show you a demo to prove that why does this word even matter and what does this word even mean to anyone? What does the latency actually means? And for this, we have to check a website. And I'm pretty sure all of you know about this website, which is Next.js. I opened this up, clicked on this, instantly loads up. Pretty good. And there's another website which also is pretty famous, olaelectric.com. I opens it up, instantly it loads up, and that's fantastic. And of course, it wants to show me some pop-up and all these things. I'm not interested in that, but it's a pretty decent website. Good enough. They sell a lot of scooters as well. And if I go back onto the Next.js website, yeah, it's pretty fun. This is also pretty fun. So yeah, this is loading up pretty nicely and everything. Now, here's a very interesting thing. First of all, the interesting thing is their second icon is not loading. Anyways, doesn't really matter. Even if we go on to this part, what you'll notice, I can right click on this, click on the inspect, and now click on to the network part. This is where a lot of magic happens, but initially when you're developing something either on backend or the front end, you don't actually think a lot onto this one. So let me show you. In the no throttling section, go ahead and change it on to 3G. It looks like that you're watching the video, I'm making the video, that everybody is on the fast internet, which is not true. Not a lot of people are actually on the fast internet. So if I click on the 3G, now let's change and see the difference that what's happening. First of all, if I go on to website like Next.js, now it seems like it's not that fast, but the first pane that you see on the website, it's pretty fast. Although the website is still loading a lot of things behind the scene and it's trying to make it active, but the first portion of the website was almost instantaneously. This is not the only website that has it. If you go ahead and look onto the clerk.com, of course, it's not that flashy fast now, but it's fairly fast. Notice here, the amount of requests that it is still sending and getting us the data, this is insane. It's doing so many of the things on the back end. And if I go ahead and keep on scrolling, it will do so many of the things. But on the other hand, if I go ahead onto the website like Ola Electric, now notice it, what's happening. All right, so we can see that decently fast, but not that flashy as it could be. Now, before making this video, I actually checked this website and it was not that flashy. But look at this, the network activity that is happening. Clearly, a lot is going on than just making the plain website. All these big giants, they have high-end engineers and they know how this latency things needs to be taken care of. And this is exactly going to be our discussion entirely for this video. Hope the premises is good and you are enjoying that part. So first of all, let's establish what the latency is. And latency has a lot of meaning on that. But the most common one is, let's just say this is the user browser. It could be a mobile browser, it could be a web browser. Any browser would work absolutely fine in this case. Now this is our browser and this is our web server. Let's call this one as server. Now server doesn't need to serve just the backend. It could be serving just the first initial of a website. It could be Vercel, Netlify and anything. When a user makes a request to the server and for the very first time, whatever the chunk of data get received by the browser itself, that is usually considered as latency. And it's not like the latency is this much of it. We have a whole variety in the latency itself. And just not to surprise you, there is something known as network latency. We also have application latency. This is where you actually fix a lot of your backend. We'll talk about that one as well. Apart from this, we have rendering latency and we also have the third party. These are the major one, but of course, depends on from where you are studying. You might have many others as well. Let's go ahead and talk about them briefly, what happens in each of these latency kind of a thing. The network latency is the client and server communication. This is something which you can speed up if you are including things like CDN networks. So networking as closest your server will be. If I am being served, I would prefer to being served from AWS of Mumbai rather than US East Coast. I would prefer that because it will reduce the latency. It doesn't feel much when you're on the faster internet, but once you try to turn things into 3G or the slow internet, it's actually visible. Then we have the application latency. This is where your backend majorly stuff comes up, but you also have to come up with the front end part of it. How often you are making the web request, or your backend, are there too many joins in your backends, or how much the backend is actually serving? How does the first rendering looks like? So this is your application. Then the next one is rendering. This is where majority of your front end engineering comes into the picture. A lot of people think that the front-end engineering is mostly about writing the API calls or just the Reacts or components, but no, this is where the engineering of the latency comes up in the rendering. Like how fast your browser were able to paint the first picture, and could you actually delay some of the calls? A lot of engineering goes up, we'll discuss them. And then the third party. Maybe your application is loading some more things to check where the users are clicking up. Where that thing should go. Actually, that should load up first, or that should load up at the very last. And there are a lot of tracking abilities, like there are people who are tracking through the Google ads, people who are tracking through some Hotjar kind of a thing. A lot of things goes on. And these days, maybe you want to have a pop-up on your website where user can contact you. All of this actually comes into third party, but this rendering part, this is where a lot of front-end engineering goes up. Now, to give you some more perspective on this, the whole part is that this latency is actually closely related to the UX part of it. Latency can totally destroy the user experience. And there is a noticeable delay or lag when you start actually feeling it. For example, if you have, let's just say, 100 millisecond of this, yeah, you start to notice it, but not too much. We are accustomed to have 100 millisecond of the lag. But if you go ahead and change this to 1 second, people will easily notice that, all right, my website is taking 1 second, and take this to actually 3 seconds of the delay, and you will notice drastically that people don't have patience of 3 seconds of load time. And you're thinking 3 seconds is okay, but it is actually well documented stuff by the AWS team that if your website is having 3 seconds of delay, people will bounce off. Even Google will actually punish you for having a 3 seconds of the delay in the first pane. So again, first, the 1 second delay is also kind of not that acceptable, and 100-second also feels like, that's a lot. People prefer under a kind of a 50 milliseconds or 60 milliseconds of delay. But how you can actually go ahead and find the delay of your website. That's why I say that always go ahead and monitor. You cannot improve anything if you're not measuring anything. Measurement is the cause. Measure the things. Let me show you some of the interesting part. And by the way, I mentioned the link in the description section as well. The Site24x7, these folks actually provide a lot of stuff for the engineers for free, absolutely free. And you can actually monitor a lot of things. So if you happen to monitor, even if your portfolio website, just try to look at what happens onto your website. So I am onto this web section. So if you go ahead and look on this, there's the first web section. And what we're going to discuss briefly on this is the website as well as the REST API as our example to actually understand what happens on that. After that, I'll also walk you through with one of the this paper as well, which is a case study, pretty interesting one. Everybody should actually go ahead and read this one. I will walk through in that part as well. So first of all, let's see what's 100 millisecond, 1 second, and 3 second. Is it just that kind of a latency? No, it's not like that. If you go ahead and look onto this website, let's just say we work on this example.com, whatever the website this is. And you can just click on this and they will show you this whole thing. Notice here, this is the response time. So you might be thinking, all right, so this is 132nd milliseconds of the response time. I should actually work to fix on this. No. If you're not measuring, you will always see that, okay, I have 137 of millisecond of response time, but it's not actually true. The response time is further divided into multiple of things that are happening once you first make a request on the website and get the data back from it. So notice here, the first one is actually the DNS time. This is probably not much in your control. The time where your website was converted into the IP address so that somebody can hit that IP address. It's not much in your control. After that, the connection time took 11 milliseconds. The SSL handshake took 30 milliseconds here. And when I say that a lot of time when the websites are actually deployed internally, some people don't deploy HTTPS, and that is okay. This is the reason why they don't do it. And now a lot of people might be thinking, all right, Hitesh, I get it. But why would anybody miss the HTTPS? Why would anybody not have an SSL certificate? Once the application is actually deployed in your internal infrastructure, let's just say this is your website and this is your database, the connection that is going through with your internal website and your database, you want it as fast as possible. Now, further that, whatever the data you have taken, you always have a front-loaded website which actually serves the user. So if I go ahead and have the user somewhere here, so user, and let's just say this is your user, and user is requesting you this website. This thing, I would definitely 100% I would say that I want an SSL here. I want the security here. But once the request has come in, having unnecessary HTTPS or these SSL layer is going to just reduce is going to increase the latency. I want my latency to be reduced. And this is the thing which you understand and learn only from here. So notice here, 30 milliseconds is a lot. We want to reduce this time. And then we have the first byte and the download times, which is pretty fast if you ask me. Now, would you like to remove the SSL onto your website? No, absolutely not. But in the case of internal, this discussion is nice. That's why I say, always go ahead and study. If you don't measure, you cannot go ahead and improve. I'll take back onto this thing again, but first let's go back up here. All right. So if you go ahead and look onto this, some companies even go ahead and measure these things pretty closely. For example, I'm just giving it, let's just say every additional 100 milliseconds of delay can actually use, let's just say it actually translates into 1% of the user drop. Let's just say this is the metrics for Amazon. Of course, it is not. I'm just making this up. But you get the idea that once you start measuring these delays in the user drop, you can actually go ahead and relate it to the revenue drop as well. Maybe you have launched a startup product and that product is good and you want to address some of the tagline, but user comes to your website and the tagline is not even loading, or maybe you want to show him some certain image which makes sense, and that might be your call to action. So this whole thing can actually be a dramatic experience. So first of all, let's discuss the big impact. I have some certain pointers which you can take. So why does the latency happens? If you understand some brief points of why it happens, I'm pretty sure you can make up your website, both front end, back end, database, everything can be optimized briefly on this. First of all, there is most important thing, which is inefficient queries. This is the most common and the most common culprit of doing the things. If you have n+1 problems, if you don't know what is n+1 problem, just let me know. I'll make a separate video on that comment. But inefficient query is the number one reason of having these kinds of latencies. Your queries needs to be optimized. There are also chances that whatever the query you are doing, that query is fine, but there could be a slow algo. Now, this is not, I'm talking about the data structures and algorithm. Maybe the things that you are doing might have certain things like maybe there are some blocking operations, blocking ops. You might want to fix them as well. This could be one of the things. Maybe you are writing the files. Maybe you are not using queues. There are a lot of things that can go wrong. Maybe you are sending email to each user on that time, on that controller, but it could be an operation that could be handled by the queue system. In that case, definitely the slow algorithm is the culprit here. Now, again, these kinds of things like, hey, mail can be done by the mail queue or a separate queue in itself so that we can have a faster operation. These things you learn eventually, but this could be one of the reasons. Now, this is majorly on the backend side. There are things that happens on the front end side as well. The most common one is, you might not believe it, but this is too many re-renders. Yeah, that's the front end culprit. A lot of people who are just getting started in writing the React, they don't have much of the idea how the React works internally, and they accidentally put a lot of re-renders on the website. This is a culprit. Another thing, which usually is the one which nobody actually looks onto it, I'm pretty sure you look onto the images. I want to make my images optimized. I want to use SVG or WebP images, but what you don't look onto this is font. Yes, fonts can be really, really heavy, and make sure you're using the font which is not only just looks good, but actually is lightweight. Some of the fonts are too heavy and they actually don't load your website. You are doing everything right. Renders are good, your images are good, your first paint time is good, but when the text actually loads up, it's a painful, slow experience. I have personally dealt with one such experience. That's why I'm sharing this one here. Now, there is also network related issues that you probably can use and can work on with that. There is something known as RTT, or also known as long round trip times. So how much for sending the request and getting back. If your server is on the another continent, it's going to work there. So common thing which you can do here in the network is CDN. But again, don't do just the CDN just like that. Measure them. Which CDN might perform well? There might be a CDN in Singapore. There might be a CDN in Mumbai. The Mumbai one might be slower and the Singapore one might be faster there. And yes, there are a lot of things that can go and surprise you. But again, go ahead and look into this. So if I go ahead and look into the REST API and look here, notice here, if we go ahead and take any of the example, they have so many of the example. Let's just say we want to check onto this trace form. Notice here, they also mention all these things up here. And probably we should check something, another one which has more data, REST API. Can we go ahead? And here we go. We can check this one. So notice here, again, response time and all of this. Notice here, the DNS time is too much. Probably we want to change our DNS provider or whoever is resolving our DNS. And after that, the first byte is 163. So there is something going on. Probably we can work on. Now, wherever this REST API is being served, we might want to work on that particular controller, that particular REST API. And if by doing anything, if we go ahead and reduce this time, then only we'll approve that changes. If by doing anything, if it improves or if increases our time, I will not approve that. And doing these things, I've seen so many developers who does all of this by gut feeling. No gut feeling is required here. Go ahead and measure the stuff. I don't know how many times I'm going to say this, but go ahead and measure the stuff. All right. And there is also a very interesting thing where CDNs can actually help you. Now, recently, Amazon CDNs have improved like drastically. We have personally seen that whenever the content was served on the mobile, it was performing not so well, but whenever the content was being served on the desktop, it was performing well. We eventually find out that the mobile network on certain areas was not really good, so we cannot do much on their side. So go ahead and work on with that, and all these things we could be able to find out just because we were measuring the things. Now, one more thing I would like to measure and would like to tell you, there are things known as third-party APIs. And you might be thinking, I don't use any third-party APIs much, but let me give you an example. Do you use PGs, payment gateways? Yep, that could also be a cause of latencies. Some of the payment gateways perform really well, like Cash-Free, Razorpay, they perform really well. Some of them may be a new player in the market, not performing that well. So not only just you have to measure your own performance, you also have to measure the performance of what other third-party providers are doing. So payment gateway is just one such example. You might want to include other, like some players, I'll give you another example. Like some of the players are there in the market like ImageKit. A lot of people think I'll probably self-host my website. Surely you can do, but the people like ImageKit, they pioneer in serving the images or media asset. There are companies built on top of this. So the way how they treat the media is completely different than how you will be treating the media. And it's not just ImageKit, there are other thousands of service providers which goes like that. So what I'm saying is go ahead and measure them as well. Measure your payment gateway latency, measure your image serving latency, and how well these things are actually going ahead and doing that. So again, this is all going for that. Now, some fixes I can definitely go ahead and discuss because we have also implemented them, starting with the front end things. So on the front end, what I recommend is there is this magic thing known as lazy loading. And a lot of routers, even 10-stack routers, Next.js, they all support this. This is a magical thing. You will immediately see that the things which should be lazy loaded should be actually lazily loaded. And also another thing is code splitting. This is 101 technique for improving the latency. There are things in the React like suspense and a lot of things which can actually do this code splitting quite well. And what I recommend, at least your hero section should be all text, less of the images. You will noticeably see the difference and you will see the pattern here as well. Let me show you. This probably is still loading, probably not. But if you'll notice, let's reload this. And what you're going to notice that it takes time because the home page is the image itself. But if you look at the other website which instantaneously load, look at this. On the smaller one or they have just the text, and the text actually loads almost instantaneously. And if I go ahead and look at the clerk, they're also a pretty big company. Notice this, all text. So there is a design reason. It's not like that it looks good. There is a design decision, there is a UX decision where latency also played an important role, that hey, we need to actually split this code. We need to serve the first thing as just the text so that at least the slow users get to see something. Also, a lot of people take this as a granted these days, but minifying your code actually still is one of the most important thing. And also go ahead and try to use the browser cache. Yes, there are ways how you can use browser cache and even the local storage of browser efficiently. These are some of the tips that I would say that every front-end engineer should actually learn, master, and see their impacts. What happens when you do them? What happens when you don't do them? Now, on the backend side, it's actually kind of not that much surprising. First of all, you want to optimize your DB queries. Go ahead and do that. That's the obvious one. And also go ahead and try to use async. As much as you want to use async, try to use it more. There are some heavy end operations like file handling. Sometimes a lot of heavy tasks are there. Go ahead and try to do them in the async way. This will reduce a lot of load on your backend. Most importantly, if you want to go ahead and use, if probably, not always required, maybe you want to use something like Redis or Memcached for the caching of the things. And another thing which I would recommend to a lot of people, that not only just these, try to use queue system. I have noticed that a lot of initial engineers in their initial days are not even aware of the queue system which is available to them, and that can actually improve your backend quite a lot. And adding a queue system is not that hard. You can actually use BullMQ. A lot of people who actually use Laravel, they actually are aware of the queue system, so try to use them. But I would say that on the backend side, these are the 4 things where you should focus on improving this. Optimize your query, try to use async as much as Redis and queue. These are like match made in heaven, and you want to try to use them. And then let's come on to the network side. What can be optimized in the network side? First of all, try to pick your CDN. And CDNs comes in a variety of companies. AWS provides the CDN, Google provides the CDN, Cloudflare provides the CDN, Akamai also provides the CDN. Which one works best for your use case? Only you can go ahead and find this out. Also, I would say that not only this is not a part of networking only, but try to compress your payload. Some of the companies which serves heavy end graphs, like companies like Zerodha, they use this technology quite a lot, where they gzip the things or throttle the things. Like these are compressions, so you want to compress your payload as much as possible. This should also be a part of backend, but I would consider this in somewhat range of the network part, but again, you can shift that. Now, also another thing which I recommend everybody is to reduce redirects. Every single redirect that you have is going to have some kind of a cost on your operations. So try to reduce them, or probably have a single endpoint where user just reach out to you directly. And after that, you do everything in your own infrastructure. That is always a good thing. Now, lastly, the most important advice that I can go ahead and give it to you is monitor. Monitor. I can write that, monitor. If you don't, this is probably the biggest advice that I can give you. If you don't monitor it, you're not going to improve it. And there are a lot of things. There is real user monitoring, a term, RUM. Oh, yeah, that's a term. A lot of corporate people actually know about this, the RUM. Real user monitoring. It's not actually the RUM that you're thinking, it's real user monitoring. There are a lot of tools available for it, but I would say that, hey, go ahead and monitor this. And take this as an early on habit to go for that. Now, once you are aware of this, I highly recommend to use a Site24x7. They have a generous free tier, and you will, for the very first time, you'll get to see that, all right, I have my website, I can see that, improve it. And then you can write it in resume as well, that the first website that I built, an e-commerce store or a chat store, this was having this much of latency. But with the monitoration and the constant visibility on the website, I was able to improve it. Now with this, I would like to mention this very interesting thing. So I'll leave this link in the description section as well. This is ManageEngine.com/IT operations management. They actually offer a lot of things here, like monitor and manage business critical operation. This is like a whole suite. Where you have to go is scroll a little bit, And this is where the gold mine is hidden. Go ahead and keep on scrolling, and this is where you see the ebook as a default. But what I recommend you is go into the case study. I have not looked in all of them, but where I have looked in, I'll walk you through. Just scroll this a little and go into this Victoria University. They probably have a lot more as well, and I need to dig up more that what is the gold mine that they are silently hiding in front of everyone. But this is the one which is very interesting. I highly recommend. Click on this. I have already opened this up. This is really nice. Australia's Victoria University optimized students' learning experience using Op Manager. Now, I am kind of an edtech guy. I love to build an edtech ecosystem. So this one caught my attention, and I highly recommend that how they nicely draft this, that what is the challenges faced by this. Notice, look at the scale. Victoria University IT infrastructure is comprised of 1,500 devices, 500 Windows and Linux servers, and 2 data centers. So already you can see the scale of this infrastructure. And how does this software help them? The whole case study, nicely well drafted, and they have ops manager and stuff. So this will give you a brief idea of how things actually goes up. And they have a lot more. I was just reading this and evaluating that how we can utilize this. So all right. So the goal of this video was to introduce you onto that side of engineering, which is less discussed. We discuss React, we discuss the backend. But some of these things looks very boring, like who will work on optimization, who will work on monitoration. But these are critical part of your application. Once your application is built, this is where, and this is how you improve your application constantly. And this is the improvement. This is where you call this as, hey, we are maintaining the website. This is the maintainability of the website. Not all the time developer needs to constantly add features. Maybe the features are good enough for your website. Now what you want to do is optimize those features so that your website feels like instant. It feels snappy. It should always feel snappy. So this is it. A very raw video, but I hope you have enjoyed this. I love to share these kinds of thoughts absolutely rawly, that what I have studied over the years during building a lot of applications. I hope this video was helpful to you. That is it for this video. Let's catch up in the next one.